How do nested JavaScript array iterations affect performance? Imagine trying to organize a huge collection of data with multiple layers. You might think about looping through each layer one by one. But what happens when you nest these loops? Let's find out. When you have an array inside another array, you often need to go through each element of the outer array and then each element of the inner array. This is called nested iteration. If your outer array has 10 items and each inner array has 10 items, you end up doing about 100 operations. That's because for every item in the outer array, you loop through all items in the inner array. Now, if you increase the size of either array, the total number of operations grows very fast. For example, if the outer array has 20 items and the inner array has 15, you will perform around 300 operations. This exponential growth can slow down your program, especially if the arrays are very large. The type of loop you choose makes a difference. Traditional for loops are usually faster than higher-order functions like for each, map, or reduce. This is because for loops run in a single scope and allow you to control the flow better. Higher-order functions create extra functions during each iteration, which adds overhead. Using functions inside nested loops can also increase memory use. Creating many temporary functions or objects can trigger more garbage collection, which slows things down. Modern JavaScript engines are good at optimizing simple for loops, but complex nested loops with lots of function calls can still cause slowdowns. If your data is very large or deeply nested, performance issues become more noticeable. To improve performance, you can try to reduce nesting levels or flatten your data structure. Caching array lengths in loop conditions can also help, as it prevents recalculating the length every time. Moving calculations outside of inner loops reduces work during each iteration. Sometimes restructuring your data or using different algorithms can make a big difference. Profiling your code helps identify where the bottlenecks are, so you can test different approaches. Remember, when working with nested arrays, always consider how many operations you are performing. Choosing the right looping method and minimizing nesting can keep your code running smoothly. This is especially important in web development, where fast, responsive applications depend on efficient data handling. Whether you are processing tables, grids, or multidimensional data, mastering how nested iterations affect performance helps you write better, faster code.